on operator overloading, and today we're doing operator overloading and builders. So I hope you guys will enjoy this one, and let's start with reading the docs. Just give me a second, I have to check something very quickly. Android. All right, so we're ready with the project. So let's open Fleet, our editor, close all tabs, and let's go to our main function so that we set up everything here. Whoop, test lambda. Okay, so let's start reading the docs. So operator overloading. Kotlin allows you to provide custom implementations for predefined set of operators on types. These operators have predefined symbolic representation like plus or star and precedence. To implement an operator, provide a member function or an extensor function with a specific name for the corresponding type. This type becomes the left-hand side type for binary operations and the argument type for the unary ones. To overload an operator, mark the corresponding function with the operator modifiers. So you can have a function which you mark with the operator, and this will allow that function to become like an operator. So when overriding your operator overloads, you can omit operator, and so yeah, in this case, if you want to have a class that is overriding this get function, which is an operator function, then you don't need to specify the operator modifier. Okay, so unary prefix operators, for example, plus a, minus a, and star, yeah, question mark, no, sorry, not question mark, but exclamation mark a, and these are called unary operators. So for example, an expression performs the following steps, determine the type of a, let it be t, for example, looks up a function unary plus with the operator modifier and no parameters for the receiver t. That means a member function or an extension function. If the function is absent or ambiguous, it throws a compilation error. If the function is present and its return type is R, then the expression plus a has type R. These operations, as well as others, are optimized for basic types and do not introduce overhead of function calls for them. So as an example here, you can here's how you can use overload the how you can overload the unary minus operator. So you have a data class, you have an operator function, extension function unary minus, which just creates a point with minus x minus y minus y, and then when you have a point and you perform minus point, it will override the implementation for minus, and it will use the function that you have specified here, so it should return the type that you mentioned here probably. So let's try and run this code, test operator overload. So this probably overload means overriding the implementation for that kind of function, for that kind of class. So we have our data class, we have our operator function, and we have, so what I want to try and show here is, okay, we have overridden point implementation, and so we should get what they mention here. So x and y minus 10 minus 20. Okay, increments and decrements. A++ is increment, A minus minus is decrement. So the inc and decrement must return a value which would be assigned to the variable on which the plus plus or minus minus was used. They shouldn't mutate the object or in which the inc or dec was invoked. So let's try. Let me see. Oh, I have to do it like this. Okay, so bring minus point, perfect. So let's try and do the same for inc. What it should do here is +1, and let's do +1 on both x and y, and let's try and do it. So point +1, and let's see the result. All right, and result plus for operator plus. Oof. Let me try like this. Val cannot be reassigned. Yeah. Let's try and put a variable just for testing it. Yeah, printing. Let's try and run it like this. But yeah, it's working. So as you see, as soon as we change the implementation of inc and we call the increment, it will behave as we want. So if I say +2 here, it will do +2, and +1, it will do +1 there. You can do the same for minus minus. Then here you have all the other operations that you may want to override. Let's just keep them. So you have all of these. This is range to, range until, which might be interesting. Okay, the in operator B contains A. It's also nice to know that you could override this. They probably on point, let's say. So contains, yeah, contains should have a point, I think. Let's return boolean. So yeah, of course, since it should check if point is contained, so it should check if x dot, not x, sorry, but this dot x equals to this dot y. B contains A, so we should have a list of points. And if this, here it should be this dot any, if there is any element x in which we have x equals to other x and it dot y, it dot y equals to other dot y, then we have a point that is contained in the list. Let's check if list of point 1, 2, point 10, 20 contains point. Contains, oops, it's in parentheses here, right. I don't know why it's glitching the UI of it's glitching, so it's a bit bad. It's saying false. Okay, we have incremented it, so that's why probably. So we should have 1122. Let's try with 1122. Yeah, it returns true. Great. Okay, so we can override also that method. We can override the get and set. And yeah, you can set also multiple elements. Then square brackets are translated to holes to get and set with appropriate numbers of arguments. So yeah, as many square bracket elements you put, as many you will have in the set. Then the invoke operator will be yeah, this will be translated to the invoke operator. So you could override the invoke operator. That might be useful. For example, if you have like a function that you call my use case, my custom use case, and you do operator fun invoke, okay, so this should be a class, sorry, and you override, I think we saw this last time also, write your own use case here, and then if you call my custom use case like this, it should call the invoke. So have I missed something? Uh, Let me check. Operator function from last time. Oh, because I'm returning it, probably. That's the issue. So you can override the invoke. No, it's still not working as I want. So yeah, this should be uppercase, by the way. But that's not the issue. Okay, override fun. Yeah, we're overriding it. Not understanding what the issue might be. So we have our class. Okay, we're returning a type here. Oh, that's why. Yeah, but I didn't mean this. Let me check something very quickly. So, ChatGPT. So let's do new chat. All right. So now, let's do fix. Let's see. Operator. Oh, I have to call it again then. So this is properly done, but no use case. Probably I need to do something like this. So this will instantiate the class, but in order to call the method, you have to, yeah, you have to just call the method of that class basically, which is going to be the invoke. So this is useful if you want to define some use cases for your app. So for example, this use case could be, I don't know, start car or stop car and so on. And this is a nice syntax for that, because then you will have here start my car use case, and here you will have starting the car, and when you want to call the use case, you say start car, you declare it on top of your function, and then you just say start car, and that will do it. Okay, next, let's go on. Yeah, you have argumented assignments, so plus equal b and so on, so plus sign, minus sign, and so on. Then you have the equals, the unequal, greater than, less than, and so on. And then you have property delegation patterns, which are described in delegated properties. We have already seen these. Infix call for named functions. You can simulate custom infix functions. I think we have seen this. Yeah, we have seen this already. So let's just jump to the type safe builders. So let's do a minute of pause. I will start a new function here. Let's create this. I want to zoom in a little bit for you. Edit. I don't know this ID. Okay. So it's a little bit long, but building. We'll see what we can do. So by using well-named functions as builders in a combination with function litters with receivers, it is possible to create type-safe statically typed builders in Kotlin. Type-safe builders allow creating Kotlin-based domain-specific language DSLs suitable for building complex hierarchical data structures in a semi-declarative way. Sample use case for these builders are generating markup with Kotlin such as HTML. All right. So here you can create an HTML with DSL syntax and configuring routes for a web server. So with Ktor, and probably also Gradle uses DSL. So when you specify the Gradle configuration, then you are using DSL as well. So yeah, for example, here you can see that routing uses DSL because you can define your routes inside this Ktor plugin with a simple way, like in a DSL manner. You can say route and handle and call respond text to print out hello when this API is called. And so here you have results. In this case, we're creating an HTML. You can say head, body, blah, blah, blah. I have, okay. Let's go on. How it works, assume that you need to implement a type-safe builder. First of all, define the model you want to build. In this case, you need to model HTML tags. It is easily done with a bunch of classes. For example, HTML is a class that describes HTML tag defining children like head and body. So HTML is actually a function that takes a lambda as an argument, and in particular this lambda argument is going to be an init function that is an extension of HTML and returns a unit. So in this lambda you have to return an HTML. Sorry, so init, yeah, this means that you need to pass a class that then will be an instance of HTML with 0 arguments in this case. And then in this case, we're creating an HTML and we're calling HTML init. And this way you can pass multiple functions or yeah, or any like expression you want to the HTML init function, and this is allowing us to create this type of syntax. Let's look at the body of HTML as defined above. It creates a new instance of HTML, so then it initializes by calling the function that is passed as an argument. So as we just said, we are instantiating HTML, then we're calling html.init, which is a function passed as argument. So it's like a nesting of things. And also it returns that instance. The head and body functions are defined similarly to HTML. So yeah, they will have a head here, and the only difference is that they add the build instances to the children collection of the enclosing HTML instance. So they have a children, and they do children.add, but they didn't say what's a children. So it will be actually these two functions do the same thing. So you can have a generic version init tag. So yeah, they're doing a generic version. Okay. So now for functions, and now your functions are very simple. They just do this, and you can use them to build head and body tags. One other thing to be discussed is how you add texts to tag bodies. In the example above, you say something like head, then you have title plus HTML, and this is going to have an operator function that does unary plus and does children.add text element this. Okay, so it passes this as a children. Basically, it creates a text element and adds it to the children's. Scope control DSL markets. So when using DSLs, one might have come across the problem that too many functions can be called in the context. You can call methods over every available implicit receiver inside a lambda, and therefore getting inconsistent results like the tag head inside another head. So this should be forbidden. In this example, only members of nearest implicit receiver must be available. Head is a member of the outer receiver, this HTML, so it must be legal to call it. To address this problem, there is a special mechanism to control receiver scope. So to make the compilers start controlling scopes, you only have to annotate the types of all receivers used in the DSL with the same marker annotation. For instance, for HTML builders, you declare an annotation HTML tag marker. All right, so let's say annotation class is called a DSL marker if it is annotated with a DSL marker annotation. In our DSL, in our DSL, all the tag classes extend the same superclass tag. It's enough to annotate only the superclass with HTML tag marker. And after that, the Kotlin compiler will treat all the inherited classes and as annotated. Okay, so you don't have to annotate HTML or head because their superclass is annotated. After you have added this annotation, the compiler knows which implicit receiver are part of the DSL, so this will give an error. But if you do this HTML, it will be possible. You can also apply DSL market annotation directly to function types, and you need to add target annotation target.type. So yeah, full definition is going to be here. Let's see here, using builders with builder type inference. Kotlin supports builder type inference, which can come in useful when you are working with generic builders. It helps the compiler infer the type arguments of a builder call based on the type information about other class calls inside its lambda. Consider this example of build map usage. So yeah, you do put hole put. This is not enough type information here to infer type arguments in a regular way, but the builder inference can analyze the calls inside the lambda argument. Based on the type information about put hole and put calls, the compiler can automatically infer type arguments of the build map call into string and number. Builder inference allows to omit type arguments without using generic builders, writing your own builders. To let builder inference work for your own builder, make sure its declaration has a builder lambda parameter of a function type for the receiver. There are also two requirements for the receiver type. It should use the type argument that builder inference is supposed to infer. So yeah, for example, you have this build list, should provide public members or extensions that contain the corresponding type parameters. So okay, postpone type variables. Okay, so I think I'm gonna stop here because it's a little bit long on let me see. So make a short recap of so let's see. So yeah, the core idea is that you can build type safe DSLs in Kotlin using function literals with receivers and well-named functions. So basically, when you want to create a builder, you have to create a function that has as argument an initiator function that that uh, has the type that you want to return and the arguments that you may have as for this function, and then it will return a unit, so it will return nothing. So basically, in this case, you initialize the object that that you want to then return, and then you call the function that you have here with its receiver type, which is HTML, and then you will be able to basically pass a function to this HTML function. And this might be useful also when you want to add some children to this initial receiver, like HTML receiver. And so in that case, you may want to have an operator function that does children add, and that will add some element, create some element with the string that you're passing, for example. So for example, here you're passing plus hello, and this will just add a children there. So you can use code reuse if you, of course, have a generic type. And you can use DSL marker and HTML tag marker to prevent access to other DSL receiver unless explicitly referenced, so as to avoid confusing errors. So it's ideal for markup, it's ideal for configuration, and it's ideal for complex tree structures. Of course, it's not ideal for all functions. Okay, let's check this one with a short recap. So builder type inference allows Kotlin compiler to infer generic type arguments inside builder side lambdas based on usage within the lambda body, especially useful when working with generics like build map or build list. So yeah, like map and lists have these type of builders for them. The compiler postpones inferring types until it sees how they're used in the lambda. It collects the information from functions like add or put, type declarations, method calls and extensions using the type parameter, callable references like get. Requirement to create your own builder with inference. The lambda must be of a function receiver, of a receiver function type. So for example, like this. So we have a mutable list of generic type. The receiver must expose public members using the type parameter. So the type parameter will be passed inside the function. Inferring multiple type arguments. So the supported features are this, and inferring independent types across multiple builders lambdas, supporting types as lambda parameters on return type. So for example, you can call build list. So this is the builder for a list. Then you say add hello, and then you can say, okay, get 0. So let's try this one. Let's run. So yeah, we're printing hello, which is the first element, then we're printing result. So this build list needs a mutable list to be passed. It allows generics, so I can pass a string or an integer or whatever, and then it calls this contract function that we don't know what it does, but then it calls in place, and then it calls build list internal. This will call another function, check is mutable, is read-only, return. If length is greater than 0, it returns this, else it returns empty. So basically it returns the list in our case. So if regular type invariance works, builder interface isn't triggered. It's enabled by default in Kotlin 1.7. If I try to add one, it will say it's not possible. As you see here, the integer does not conform to the expected type string. So you cannot have a build list numbers. Sorry, add one, add seven. Then it will infer the proper type. So the types must be the same. They cannot be, they cannot differ inside the build list. Yeah, then you have all these annotations that will probably do some checks. Okay, so I hope you guys enjoyed it, and we'll see probably how these work if we have a course on Ktor, which might be interesting for you. So if you guys want to see a Ktor course, please write that into a comment. Ktor is a library for generating clients and servers for your Kotlin projects, and it's very useful. It's also multi-platform, so it can be used on all platforms like desktop, Android, iOS, etc. So it's a very interesting library. So let's go on next time with more concepts that we may be missing, like null safety, quality, this expression, asynchronous programming techniques, and annotations, and destructing declarations, reflection, and what else. Okay, so thank you guys for watching, and see you guys on the next episode. Bye bye.